This video is going to go through our physics homework. I'm going to read through the text first, and then I'm going to go through the questions and give you some clues and pointers where to find the answers. TLD badge, how it works. Radiation workers who work at a nuclear power station or in nuclear medicine must wear a personal dose meter which measures their radiation dose. It is normally worn all the time they are at work. One type is a TLD badge. The card inside the badge holder has two round areas made of material that stores the energy from the ionizing radiation until it is heated. When it is heated, the energy is released as light. This is where it gets its name. TLD stands for thermo or heat, luminescence, light, dose meter. The card inside the badge holder is sent away to be processed at regular intervals. When the card is heated, the light released is recorded and then the card can be used again. One round area is under an open window in the case, that's area A there, so that weakly penetration can reach it. The other area is under a thick filter, that's area B, so that weakly penetrating radiation cannot reach it. So, question 1 says, if you didn't have a badge, would you know if you had received a radiation dose? And explain your answer. So we're looking for a full sentence here. So think about it. Can you see radiation? If you were walking around a nuclear power station or working with nuclear medicines at a hospital, could you see the alpha, beta or gamma radiation? And that will give you a clue how to answer question 1. Question 2. What would happen when the card was read if the worker A had not been irradiated, so that means not exposed to any alpha, beta or gamma, and B had been exposed to a high dose of radiation? Now we need to think about how the badge works. So I've put on this slide the relevant paragraph from that text you've been given. So we're told, and we can see that here, that they take the card and they heat it. So when it's heated, any ionization energy is released as light. So if that circle A or B has experienced radiation, there'll be energy trapped in it, and when you heat it, it will release light energy. If you've not been exposed to that radiation, then the energy won't have been absorbed, and so when you heat it, will there be light? That's what this question is getting at. Question 3 then. Which type of radiation would go through A, the open window A in the case, and B, the thick filter B? So I've put some picture clues on here. So open window A is this section we're looking at here, and our thick filter is B, and that's here. Look, high quality animation going on there. Now, with window A, the yellow circled one, there is nothing blocking that card detector there, okay? So you need to think, right, which radiation is going to be able to get to that? Is any of them going to be stopped? So you're looking at listing alpha, beta or gamma, 1, 2 or 3 of them for that one. Then for B, we've got a thick filter, thick bit of plastic over that circle. What radiation is that going to stop? Okay, and you've got the picture there that we've seen in class of alpha, beta, gamma travelling and their penetration depths. Question 4. Explain how the badge would show that the worker had been exposed to alpha radiation. So this is asking you, when you look at these results on the card, if someone's been exposed to radiation, one or both of those circles is going to glow when heated. Okay, now we can see that this case has got a filter on. What do you think? What is going to be stopped by that one? And we've got this one here. Is anything stopping any of the radiations getting there? What is the difference between those two circles? And how might that tell us that someone's been exposed to alpha as opposed to beta or gamma. So it's kind of like, what would be the difference you would see between those two circles that would indicate it's alpha radiation? This one's a bit more challenging, this question, but do have a go at it. But compare what you'd see those two circles if it's alpha radiation as opposed to beta or gamma.